Let's take a look now at 5.8, which really just deals with some vocabulary as well as using point slope and slope intercept to write equations of lines. We're going to talk about parallel and perpendicular lines. First of all, our goal is to answer what are they and how do we know, or what do we know about their slopes? Because in Chapter 5 we've been dealing a lot with slopes of lines and their graphs. First of all, what is the definition of a parallel line? Parallel lines are two lines that never intersect. Okay, they never intersect. They go up. We could say sort of like at the same angle, right? Although in Chapter 5 we really don't talk about angles too much. Perpendicular lines are like this. The word perpendicular is one that you need to know, and you need to know it for the OGT and just life in general. The word perpendicular is used plenty of times out there in the real world. Perpendicular means at a 90-degree angle. So it comes off right at a 90-degree angle. Okay, so that's what these two words mean, and we're going to now begin to discover a little bit about their slopes. Actually, let's look at the next slide. Here we have a blue line, and it apparently starts right here and goes to here. Let's figure out the slope of this line, so we can kind of get to know the line a little better. It looks like it goes up 4. Right, so I'm going to write that down. It goes up 4, so that's the rise here, and then the run to that point would be 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 6 is 14, so the run is 14. So the slope here of the blue line is 4 over 14, which is 2 over 7. So up 2 over 7. Let's just check that. If we go up 2 and then over 1, 2, 3, 4, 5, 6, 7, sure enough, you see it hits right there, which is the up 2 over 7. So the blue line has an angle of up 2 over 7. So how would we draw a parallel line to the blue line? Let's change colors, and let's use, I guess, green would be something different here on the screen. And let's put a dot right here. So if I wanted to draw a parallel line to this blue line, I'm going to go, and I could estimate it, but you can kind of see that that's not quite right. So let's try again. And I think you're probably thinking, well, it'd have to be going at the same angle or with this same slope. So here I put a dot. The parallel line has to go through that point. So I think we need to go up 2 and over 7 to construct a perfectly parallel line to the blue line. Okay, so that's how we would have to do that there to get parallel lines. We'd have to have the same slope. Alright, let's now look at perpendicular. So here we have another blue line. Let's figure out the slope of this. It looks like it goes through this point right here, but we better not guess that. Let's only use these two. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's down 14. So that's a rise of negative 14. And then what's the run here? It looks like the run is 5. Okay, so the slope here is negative 14, down 14 over 5. Now we want to construct a perpendicular line. So we're going to have something shooting off of this blue line. Let's put a dot right here and just say, we want to shoot off of here at a 90-degree angle. How are we going to construct that perfectly? So I did a pretty nice drawing, but we actually want to make it perfect. So let's try again. I'm going to put my dot here. Now, what's going to happen is we're going to want to go, I think we're going to want to go up 5 over 14 instead of down 14 over 5. And watch what happens when we do that. And we may be in a bit of a trouble here. We might go off our graph. Let's take a look. So we're going to go up 5. There's up 5. We've got to go over 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's 10. Then we're going to have to go over, there's 1, 2, 3, 4. So our other dot is going to be right on the, pretty much on the apostrophe or on the S here. And you can see if we construct this perfectly, draw this with a straight edge, we will actually make a 90-degree angle. And let me remind you, this was up 5, and it was to the right 14. So the slope on that is positive 5 over 14. Okay, so what do you notice about these two numbers? This blue-green one was down 14 over 5, whereas the red one was a positive slope. It was up and to the right, and it was up 5 over 14. So you notice how those have the same two numbers, but the signs are different, and one is flipped over. That's called the reciprocal. So here is the stuff you need to take away here. You need to know this. Parallel lines have equal slopes. And that's totally obvious if you just think about it. Parallel lines have the same angle, so therefore they would have the same slopes. Okay, nothing surprising there. The other side here, the blue side, is going to be the slightly trickier one. Perpendicular lines are going to have opposite signs, so we're going to use the word opposite. Remember on the previous slide, one of the slopes was down 14 over 5, and then the other was up 5 over 14, and that made a perpendicular. So they're going to have opposite slopes, but it's also going to be flipped over, and the official word for that in math, of course, is reciprocal. So it's the opposite reciprocal. So perpendicular lines have the opposite reciprocal slopes. So now we're going to quickly go through several examples. If I'm given this line, this is the line that has been given to me, okay, and they want me to write an equation of a line that goes through 5, 6 that is parallel to this line. What I need to do is, my red line has a slope of 3, okay, and I got that from right here. I harvested it out. Okay, that's line 1. So now we're going to go to the other line. So on the other line, this is going to be the parallel line. What does the slope need to be on the parallel line? Well, yeah, it needs to match the red line, so it has to be the same. And it's going to go through 5, 6. Okay, and that's what we were doing in section 5.7. So our final answer is going to be y minus 6 equals 3 times the quantity x minus 5. I just plugged in the point slope and found the equation of the line. So my red line was given. It had a slope of 3, and it went through the y-axis at -1. This blue line doesn't, by the way. This blue line does not go through the y-axis at -1. But our blue line goes through 5, 6 and has a matching slope because the direction said it had to be parallel. Now let's do the same thing. Our red line has, for perpendicular, our red line has a slope of 3. I switch to red here. Our red line has a slope of 3. Okay. So what does that mean that our blue line is going to have, our perpendicular to that one? So our line 2 will be slope of a perpendicular. This upside down T is the symbol for perpendicular. Slope of the perpendicular is going to be, you got to flip the 3 over and it becomes 1 over 3, and you need to change the sign. So the red line had a slope of 3, so therefore the perpendicular, which is blue in this case, is going to have a slope of negative 1/3. Notice I'm not drawing any graphs on the board. We drew a graph on the previous page to show how this is correct. But we just know. We know these lines are perpendicular because their slopes are opposite reciprocals. All right, and the final answer would be y minus 6 equals negative 1/3 times the quantity x minus 5. Because remember, it was through 5, 6 up there in the directions, 5, 6. Okay, so I had to use the new perpendicular slope instead of the parallel slope. So here's the equation of the parallel line that goes through 5, 6. It's parallel to 3x minus 1. Here's the equation for a line that is perpendicular to the given line, and it goes through 5, 6. All right, let's go through the next example a little bit quicker. All right, so here we have a given line. This is going to be given. Okay, I want you to notice that the given line has a slope of 2/3. You can harvest that out from right here. That's your m. All right. So now let's switch to blue, which will be our perpendicular and our parallel line. So in part A, they want parallel. So that means my parallel slope is going to match. And I'm going to go through the point negative 2, 3. That was given in the directions. So the answer would be y minus 3 equals 2/3 times the quantity x plus 2. All right, now in part B, they want perpendicular. So the slope of the perpendicular, remember this, that upside down t means perpendicular, is going to be, well, our original slope is positive, so we got to change the sign on that. Then we're going to change the sign, we're going to write a negative, and we need to flip over 2/3 and it becomes 3/2. So the answer would be y minus 3 equals negative 3/2 times the quantity x plus 2. Notice everything's the same as this answer, except the slope. The slope has been changed. It's the opposite reciprocal of the given line. We had one line, and then we were asked to find the equation of the perpendicular and the parallel. All right, let's look at one more example that involves something a little different, and then we'll be done. All right, so there's something a little bit different here. I'm giving you an equation of a line. I'm saying please find an equation of a line. The line that we are seeking will go through negative 5, 1, and it's going to be parallel to this given line. So the problem here is this is not in slope-intercept form. So I can't just can't write the slope down immediately. I'm going to put a question mark there for now because we don't know what it is. So what we have to do is first solve for y so that we can harvest out the information. And of course we were doing this the last couple sections, so we know how to do this. Apparently the slope is negative 2. Okay, and I had to figure that out. The slope on the given line is negative 2. And I can write that down here now. The slope of the given line is negative 2. I'm going to now switch to blue, which is, through the course of this presentation, has represented the other line that they're asking you to figure out. The other line is going to have, that's going to be parallel. For parallel, it has to have this same slope, so it's got to match the red line. So it's going to be negative 2. So the answer is going to be y minus 1 equals negative 2 times the quantity x plus 5. Remember, I had to use this information right there. I had to use that information for my point, my x1, y1, and I plugged in the point slope. All right, now in the second part here, we have to find the slope of the perpendicular. The slope of the perpendicular is going to be change the sign on this and flip it over, the opposite reciprocal. So it's going to be positive, and we're going to have to flip 2 over 1 over, and we get 1 over 2. So the slope on our perpendicular apparently is 1 over 2. That's the opposite reciprocal. So our answer will be y minus 1 equals 1 over 2 times the quantity x plus 5. And it's, remember, it's plus, just to remind you, it's plus because we have x minus 5. All right, good luck on your homework. This is, you just learned about parallel and perpendicular lines.
Made with DoodleCast Pro.